Moritz, Haag, ETH, Zurich.
Yeah, welcome. I want today to talk about creativity and a field where most of you, I would say, wouldn't expect it that much. I want today to talk about chemistry. Chemists, very much like sculptors or pottery makers, use their creativity in order to transform materials into new ones with fascinating new properties. For example, raw oil into drugs or plastics. In order to be creative in a field, we need to have a feeling for an object's behavior. With stone and clay, that's easy because we can take it in our hands and work with it. In chemistry, however, things are quite more complicated. In order to come up with the transformations for new materials, chemists usually think in terms of molecules. If we would not just be able to grab molecules like clay, put them together, and feel their behavior, we would be immediately able to use our creativity. But that's not possible, unfortunately, because molecules are microscopic objects. So only through complicated experiments and calculations, we can develop over time an intuition and use our creativity. But what if we would be able to really interact with our molecules, to grab atoms, push and pull at them, and really feel their willingness to react? This sounds a bit like fiction to you, ladies and gentlemen. In fact, it's not. We created a virtual environment for you that lets you directly interact with your molecules and feel their willingness to react. In order to do that, we come up with ultra-fast quantum mechanical calculations that provide you an instantaneous response of the molecules to your manipulations. With so-called haptic feedback devices, you are able to conveniently manipulate this three-dimensional structure of molecules and at the same time feel the atomic forces that drive a chemical reaction. This combination of the real-time response and the possibility to really feel the driving forces of chemical reactions allows you to be deeply immersed into the molecular world and develop an understanding for them and being creative. And the best is, you don't need to learn to use it. It's a very natural and intuitive interaction. It's just you and the molecules, and you can start to learn their behavior. So chemists can use that in the research labs to test their ideas before or even replacing some of their time-consuming experiments. But also students can use it to intuitively learn about the otherwise quite abstract concepts of chemical reactivity. But also, basically, everyone else can use it, start to explore the fascinating world of molecules. And this, ladies and gentlemen, will break the wall between you and the molecules.
How large is the atomic cluster you can calculate, and how accurate is your calculation?
We can now treat molecules up to 100 atoms, but we will increase that, and the accuracy is good enough to find the important reaction steps in a chemical reaction.
Heaviest atoms that you have in these structures?
Right now we deal with the biological relevant atoms like CnHO, but we extend it now to iron and so on.